Friends, welcome to my YouTube channels. Today I am going to discuss shear force and bending moment diagram shown in the figure. That given diagram is simply supported beam and one side is overhang. A to B beam support, they have reaction force RA and RB, and BE is overhang. One side is overhang. Given dimensions is there for UDL 1000 Newton meter, 8000 Newton, 4000 Newton, 1600 Newton meter. So sometimes they will give kilonewton, sometimes they will give meter. So whatever dimension they will give, we have to solve it. So before the solving, what I will do now, I will draw the load diagram. Once we will calculate the moment, that will be easy for us. Okay, so generally load diagram will not be there, but for your understanding, I am drawing the load diagram here. So we will draw first line, then we will draw the load diagram. Load diagrams used only for concept of the taking the moment. So that I will explain that times. Okay. So here RA, as it is I am writing RA. Then just to draw the dotted line here, all the load. Okay. Now this is the here load, point load given, because load diagrams why I am drawing, will convert all the UDL into load diagram only. 8000 Newton. Again this also load diagram, this will be 4000 Newton. Now UDL, uniformly distributing load. So it's the load will act in the middle point. You see here, already so many times we discussed this. So this UDL means uniformly distributing load, this deflections will be this way. So maximum deflections will be in the middle. So for that UDL, load will act in the middle point. So middle point you will take here. So this will be the 2.5, and then this also 2.5 meter. Then what is load? UDL plus length. So 1000 into 5 is coming. It's coming 5000 Newton will come. So now we know the load here. What is distance? 2.5 meter, 2.5 meter. So load will act in the middle for the UDL. So this is the load diagram for this. Now another UDL is there. So here also we will draw the load. So this will be again 1600 into 2.5. So it will come 4000 Newton. It will come 4000 Newton. So we'll check it once. 1600 into 2.5. 1600 into 2.5 is coming 4000 Newtons, correct. So 4000 Newtons. So converted load diagram. This distance as it is 2.5. This distance is 5. This distance will come 2.5 divided by 2, 1.25. 2.5 divided by 2, 1.25. So correct. This distance is 1.25. This also distance is 1.25. So load diagrams we drawn. Okay. So load diagrams we draw now. Actually we have to calculate the moment. So that time it will be helpful. So why it taken middle? Because UDL is uniformly distributing load. Maximum deflections will be in the middle. So this load will act in the middle point. Okay. And UDL load Newton meter into 5. Meter get cancelled. So 5000 Newton. So this is the load diagram over. Now we'll do the shear force calculation. So before the shear force calculations, we have to find the support reaction, because this is simply supported beam. So we have to find the support reaction. So first we will see the support reactions. So how we are taking summation of FV equal to 0. That means total vertical forces will be 0, either upward or downward. So here what we will do? Total upward force equal to total downward force. This is the concept we will follow here. We will not assume the negative and positive. Actually downward force negative, upward force positive. So both if you will see, this force minus this force equal to 0. Finally, we can write now. Suppose this force minus this force equal to 0. Finally, what we can write? Upward is equal to downward. So that directly I am taking. I am not assuming here sign conventions. Okay. So total upward force equal to total downward force. What is total upward force here? RA plus RB. So RA plus RB is equal to downward force. 5,000. See, directly load I converted. Now 8,000 plus 4,000 plus 4,000. So total RA plus RB is equal to how much you can write? RA plus RB is equal to, is it, we have calculations for that. RA plus RB is equal to 2,100 Newton. So we have this 2,000. RA plus RB is equal to this much. Okay, 21,000 Newton. Now second we will take the moment about A equal to 0. So here also what we will do? We will not take the negative and positive. So we will go the sign conventions. We will not go sign conventions. So total clockwise is equal to total anti-clockwise we will assume. Total clockwise here upward and downward take the box. Total clockwise is equal to total anti-clockwise direction we will take. So we will see the moment is nothing but force into perpendicular distance. Moment is nothing but force into perpendicular distance. So I taken point A. A point is fixed. Now see moment, this is force. Direction is, due to this direction is clockwise. Direction is clockwise. This also direction is clockwise. This direction is clockwise. This also directions will be clockwise. But here RB. Here will be the RB. RB. These directions will come anti-clockwise due to this clockwise. So all the clockwise first will write. 5,000 into 2.5. Force into perpendicular distance 2.5 plus 8,000. 8,000 into total distance will be here up to 5. This point fixed, so this is 5. This will rotate this way, this will rotate this way, this will rotate this way, this also will rotate this way, this will rotate anti-clockwise direction. So total clockwise 1, 2, 3, 4 clockwise. So again plus what is 4,000 into total distance is 7.5. Total distance is up to force into perpendicular distance 7.5. Now this plus again how much 4,000. 4,000 into total distance will be 12.5 plus 1.25. How much coming? 5, 2, 7.5. So 5, 12.5 plus 1.25 is coming 13.75. Cutting this, coming this 13.75 equal to anti. This all are the clockwise. Anti-clockwise RB into total distance is 5, 12.5. So this is the moment. If we draw the load diagram, how much simple. Or if directly, if we'll take the moment, you just see how we are taking, how we'll take. So taking moment about A, what we'll write? See here, 1,000 into 5 by 2 plus 8,000 into 5 plus 4,000 into 7.5 plus 1,600 into 2.5 into total distance. How much? 12.5 plus 2.5 by 2 equal to RB into 12.5. If load diagrams you not draw, you have to take like this. See 5 into 5,000 into 5 load, then half distance we have to take for UDL. So here what I taken 5,000 into 2.5. See 5,000 into 2.53, 8,000 into 5, 4,000 into 7.5 because this is point load. So all converted point load. Now this is UDL again. See 1,600 into 2.5 load. So 1,600 into 2.5. This is the load 4,000. 12.5 plus 1.25, 13.5 will be RB into 12.5. So if load diagrams you are converting, taking moment is simple. What way? Force into perpendicular distance. Force into perpendicular distance. So this concept you can avoid. This concept you can avoid. This also what is? UDL half load. This UDL also half load, but this UDL is where? From the point A, 12.5. So 12.5, this distance you have to add, and half distance 2.5 by 2. So either this or this. If you are drawing this, no need to draw the load diagram. If they are doing this, you have to draw the load diagram. So any one you have to follow. Okay. So now RA equal to and RB equal to, we have calculations, we'll write directly. So RA is coming 10,000 Newton. RB is coming, RB is coming 1100 Newton. If you will calculate, first you will calculate, you will get RB, then you substitute here RB, so you will get RA. So RA and RB I know. Now we'll go the shear force calculation. Shear force diagram calculations. So carefully watch all the steps. Shear force diagram calculation. So what is sign conventions will follow. Now this I will rub it here. This already, this I did know, so this I'll rub it now here. So we'll go the shear force calculation. So before the shear force calculations, we draw the zero line of the shear force. We'll draw the zero line of the shear force, and we'll assume the sign convention. So that way we can calculate. So this is the shear force zero line. In this point, shear force will be 0. So all the projections line. So once we will draw the shear force diagram, moment inertia diagram, this point load converted will not take, that will not consider. So directly we'll find. So zero line of the shear force diagram we taken. So point A, this point A, this point CD is there now. So C, A, just you write D, then B, then E. So shear force at A will find. So before this, the sign conventions I will write here. Sign conventions, what I will follow? This is the section. This is sections. If you take the downward force from right side, will be the positive. If you take the upward side, this is left side, it will come positive. If you will go the reverse, it will be negative. It will be, downward will be negative. Left side, upward, positive, downward, negative. Right side, this is the section where I am taking, this is the section. Okay, so this is the section line. Section line, okay. This is point the C line, no? Okay, this is the C point. So, okay, section line. If you draw here, na shear force, just wait 1 minute. Space not there. So this sign conventions I will write somewhere. Sign conventions for shear force I am writing here. This is the section. Downward force is right side, positive. Upward force left side. This is the section here. Upward force negative, negative, downward force negative, left, right. Okay. So now shear force at A. Shear force at A. We'll write the shear force calculations with the different things. Shear force at A. Well, how much A? 1000. So we'll write the 10,000 Newton. Why? Taking left side, taking the left side, taking the shear force left side, positive, upward force positive. Now we'll take the shear force at C. Shear force at C. C means if you are taking here, see the load and UDL and load both is there. So if we'll take this point is left. So LC, SC, L if we'll take. What is the shear force? RA already 1000. So 1000, 10,000 minus, what is this load? 5000. So it is coming 5000 Newton. It is coming 5000 Newton. So okay, it's coming 5000 Newton. So okay, now SCR will take. We'll say SCR. SCR means just after this point. That means this point load also will consider. So SCR. So SCL means just before this point load. SCR means we'll consider the point load. So how much is there? Up to 5000 minus how much? 8000. Because downward force, left side downward force negative. So 8000 is coming minus 3000 Newton for SCR. So let's check it how we'll draw the shear force diagram. First this going 10,000. Now in between UDL is there. UDL is there. So that means this UDL will be inclined line. So up to this we'll draw the inclined line. So if UDL will be there, inclined line will be there. If point load will be there, point load will be there, straight line will be there. Okay. So this draw the diagram. Now at point C, you see here 5000 at point C. So actually this 5000, now this line is not correct. So this is the zero line. Now 10,000, you draw this line to inclined line for the UDL. For the point C having UDL and point load. So this will be the, how much we have? 10,000 Newton. But this place is 5000 here. SCL. SCL how much? 5000 Newton. But due to this load, point load, how much? Minus 3000. So here minus 3000 at point C. So what is the meaning of L and R? If you will not consider this you will not understand here. So here this point means we are not considering the point load. We are not considering the point load. At point SCR we are considering the point load. So up to this is the shear force diagram. Now we will see the shear force at, you calculate shear force at D. So up to this how much is there? Minus 3000. And again downward force is there. Downward force will be negative. Minus 4000. So how much is coming? Minus 7000 Newton. SD how much coming? Minus 7000 Newton. So now SD. So you extend this line. Then how line will be there? Because point line will be there. So up to this C and D, no load. So draw the horizontal line. And the point D, how much coming? 7000. So you take up to this 7000. Okay. Now in between D and B, no load. So it will be the horizontal line. It will be the horizontal line because in between D and B, no load. Now we'll calculate B, shear force at B. Shear force at B, it will be minus 7000 Newton. Now shear force at E. So minus 7000 up to this. Then E, how much? Here 7000. And what is RB here? RB is 11,000. So up to B, RB is going upward now plus 7,000 plus how much going RB? 11,000 equal to how much? This will come SB. SB will come 4,000. So this is come 4,000 Newton for SB. Now SE now 4,000 is there, and then UDL downward force 1600 into 2.5, it is coming 4,000. So write for your understanding. Load how much? 16 into 2.5. So this will come 4000. So shear force at E will be 0. Now I will draw SB. SB how much coming? 4000. It will go plus. Because minus is there, so it will go plus 4000. Here coming 4000 Newton. Now B point you write somewhere here. So now here UDL. UDL what is? Inclined line. So we have to draw. You have to join this. Join this. So this is your shear force diagram completed. You hatch this line like this. This is the negative. Negative should not write because already in the directions of the negative. So this is the shear force diagram for our shear force diagrams. Okay. So will be like this. Okay. So shear force diagram. This dotted line you give. This is the shear force diagrams. Okay. Now we'll draw the bending moment diagram. Now draw the zero line of the bending moment diagram. So extend this line. Then we'll do the calculations and then we'll substitute all the value and we'll draw the bending moment diagram. So draw this line here. Bending moment, zero line will draw. In this line, bending moment will be 0. So bending moment diagrams will calculate now. Bending moment diagram calculation. Okay. So bending moment at A and E will be 0. Bending moment or M, just simple writing MA will be 0 and equal to ME. So bending moment at A, bending moment at E will be 0 because this side no load, this side also no load. Remaining will calculate. So now this will be again will help to calculate the bending moment diagram. So we'll take the bending moment diagram for C, MC. Bending moment diagram for MC. So for the sign conventions I am writing here. So this is the section. I will write this diagram. See this bend. This is the section. If you take the clockwise, negative. If you take the anti-clockwise, ACW negative. For the right side, for the left side, this is the section. These sections again it will go the anti-clockwise, negative, positive, and this is going to clockwise will be the positive. So right side, left side. This sign conventions we are going to follow here. So what is the bending moment calculations? Now you check. M and ME is equal to 0. So we will take MC. So MC we are taking. So RA how much? RA is 10,000 into total distance how much? 5. Because we are taking moment about this. So moment about this your left side. Left side clockwise. Left side going clockwise positive. Clockwise going positive. See here. Plus. Minus because UDL now this will be anti-clockwise. Anti-clockwise will be negative. This RA going clockwise. Clockwise RA positive. Clockwise RA positive. Then UDL load will be at point C anti-clockwise. Anti-clockwise negative. So negative how much? 10,000. Convert into load first. 10,000 4030 no 1000 only into 5. This is the load into 5 by 2. What is 5 by 2? This is the half distance. These calculations will do now. How much will come? We'll see. So into 5. This calculations is coming 37500. So coming 37500 Newton meter because UDL this all shear force will be Newton. This Newton meter MC over. Now take moment about bending moment about D. D point. Now again RA into total distance 7.5. How much RA? 10,000 into 7.5. Why 7.5? Because this distance is 7.5. Now all the load is UDL load minus 1000 into 5. This is load. And 5 by 2 plus. Why plus I am giving? Because this UDL is from the D point 2.5 meter away. So this you have to add. D, listen again. At the moment about D, RA clockwise positive. Then this UDL 10,000 into 5 into 5 by 2, half distance, because UDL we are taking half distance. Again, how much distance from this D point? 2.5, so added. Now this point load minus point at how much? 8,000. Point load will be 8,000 into total distance is 2.5. If you will calculate this, how much will get MD? Just we'll see. MD will get here 30,000 Newton meter. So MD will be 30,000 Newton meter. This is the calculation MD we are getting. Now we'll go the final MB, bending moment about B. So space not there now, I will utilize here. So shear force, this I will rub it here and will write the bending moment at B. MB, I am writing MB. So bending moment above B. Now look here. Again RA into total distance 12.5. So RA how much? 10,000 into 12.5 into 12.5. So this is going clockwise positive. Now all will be anti-clockwise. Now see this UDL is coming. UDL how much? 1000 into 5. We convert it into load. Then half distance 5 by 2. But plus where this UDL? After 7.5. After 7.5 only UDL. This point is 7.5. So this UDL over. Now minus right here. Minus 8,000 into total distance 7.5 minus 4,000 into distance is 5. So this way you can calculate this negative, this also take in the bracket, this also take in bracket. So this will calculate now how much will come MB. Calculations is with me. 12.5, yes, 1000 into 5, 7.5, 8,000 into 7.5. So this coming minus 5,000 Newton meter. So this coming minus 5,000 Newton meter. 5,000 Newton meter. So MB we know 5,000 Newton meter. MA and ME will be 0. So now we'll draw the bending moment diagram. First MC how much? 3,000. So this line and all, draw the dotted line. So it will be easy to draw. All the calculations work over. Now we have to draw the bending moment diagram. So that way we can complete our solution. So okay. So if bending moment diagram we are calculating for UDL is parabola. UDL is parabola. Point load will be inclined line. If UVL will be there, second degree parabola. So this point A, how much getting MA? 0. So this is bending moment here 0. This point also bending moment 0. But MC how much? 3,000. So what will be line will be there here? It will go the parabola. It will go the parabola up to point C. So this value will be 37. You can write here 37500 in this point. Okay, now MD. So MD will be there, no? So how much MD will be there? 30,000. MD will be 30,000, no? Yes. Now 30,000. So in this point load is there. Point load there, na? You draw the inclined line. inclined line. So this will be the 30,000, 30,000, 30,000, 40. This point is D. This point is D. Now, again, B. B will be 5,000. So what will be the line here? Again, it will be inclined line only because you have UDL. So 5,000. So again, it will be, this is inclined line only. We draw the inclined line. This is 5,000 for MB. Now this is zero line. But here what we have to draw? We have to draw the parabola. Just 1 minute. Because UDL is there. So this is the curve line will be there here. Curve line. Curve line here. This also. Curve line. And this is straight line. This is the straight line both. It's because point load for bending moment, inclined line. This inclined line. This is curve line. Curve not looks so. Draw like this, curve line. Okay. So this way we can calculate the bending moment diagram. So calculations wise and concept wise, you have to take care carefully. So this way we can calculate the shear force diagram. Bending moment and shear force diagram. So this coming minus 5,000, 1 minute, which is minus 5,000. No, so here diagrams we have to modify. Just wait. This coming minus, when I didn't watch. This value is coming here minus 5,000. So this inclined line will go the down. Okay. So just wait 1 minute here. So this I didn't saw. This here minus is there. MB how much? Minus. So this line will come up to there, negative 5,000. Okay. So this point is B. B because given minus 5,000. Now it will be 0. So this is the bending moment diagram. We will go calculations like this. Okay. So this way we can calculate this line which will not cross. So this here will be the curve line. This is curve line. This line is curve line. So this is 5,000. This bending moment will be 0. This bending moment will be 0 at point E. Right, point E. This point is B. This point is D. So this way we can calculate the moment of inertia, the bending moment. So here up to 30,000. Now this is negative. So before what we did na, we taken 5,000 only. So negative na, it will come down at point B. Now this is the straight line. Now this is curve line. So this way we can calculate the shear force and bending moment diagram. So okay, so watch this video carefully. All the points, sign conventions, everything you carefully watch and calculate twice and thrice you revise, then only you can solve. Okay students, subscribe the channel, share this video to your friends so they can get the benefit. Okay, thank you.